of all, acceleration is, well, definition of acceleration. Acceleration is the change in velocity over the change in what? Time. That's like average acceleration. Instantaneous acceleration, we'll call A of t, is actually the derivative of what? Of velocity. So what you need is the velocity function. And if you differentiate velocity, you now have what? Acceleration. And I'll give you guys a note here. You can also see it this way. Since velocity is the position function derivative, this is also known as the second derivative of the position function. They use this notation for it. So acceleration is something we want to care about as well. So we want to find the acceleration functions too. Okay, and we'll talk about acceleration, why you care about that. And I'll go to my website. Where is this? Let's get rid of some of these things. Okay. We got acceleration of a particle now too. And the good news is about this worksheet, if I said to you, hey, acceleration, the first position function, I think that was number one that we did yesterday. So they gave you a position function now for t being greater than 0. We computed the velocity function yesterday as well. That's what we did for question 1. So if I said to you guys, okay, what's the acceleration function? Let's put that in words first. Acceleration, they're asking for this, A of t. You say, well, what's my definition of A of t? Well, A of t is the derivative of velocity, because acceleration is really the change in velocity over the change in time. Since you already computed the velocity function, I even included it here as a reminder, right? It's 3t squared minus 12t plus 9. So 3t squared minus 12t plus 9. We can actually differentiate and get the acceleration function. If I can add more paper. So what's this derivative? Isn't that going to be what? 6t minus 12? Double check. You guys have the acceleration function now too. Okay. Now we're going to have to think a little bit about this too. We have to think more about what this means. So let's take a look at what they're asking here, right? Determine the acceleration function A of t. Well, we did that, okay? And where the acceleration is 0. We got to find where the acceleration is 0. And the time for which the particle the time t for which the particle is being pulled. Oh, pulled in the positive direction now. I don't remember the colors we used. Was green positive? Pulled in the positive direction and pulled in the negative direction. Notice the key phrase they're using now. They're using the phrase what? Pull. Is that right? Does anybody know what's the relationship between being pulled and acceleration? Why do they use the phrase pulled for acceleration? Let's go back to this idea. Okay? You have this idea of force, which equals mass times what? The acceleration. So you know this as F equals ma. Is that true? And your mass is constant, so the force is a function of the mass times acceleration. Do you guys know what's the meaning of the word force? Like your 8th grade meaning of force from science. You know what a force is? What's a force? It's a push or a pull. And it's completely related to acceleration. So when they say the particle is being pushed or pulled, that's what acceleration can give you. Okay? Now, I want you guys to know these two things here. Acceleration equals 0 means there's no what? Push or pull. The same kind of ideas we had yesterday, but this time it's a push or pull. Oh, I don't know what I did. Okay. I want to do it here. Oh, I want to do it here. When your acceleration is positive, the particle is being pulled or pushed to the what? Positive direction. We said right is positive or up or forward. When your acceleration is negative, the pull is to the what? To the left. This is the key ideas centered around why you want to get the acceleration. Because you want to know, when is there no force on the particle? When is it being pulled in the positive direction, which is to the right? When is it being pulled in the negative direction, which is to the left? So I guess I'll put right. Let's go to that. All right. So this is the physical attributes behind that second derivative in terms of looking at a position function of a particle. They want to know, when does that particle have no push or pull? When is it being pulled to the right? When is it being pulled to the left? In code, what do they want you to do? To answer these questions, you got to do sign analysis on the what? On that second derivative. And then we'll put all these other things together about, you know, what this information actually means really together, but you have to give this to people in pieces. So we got to do sign analysis on this here to start to answer this question here. When do you have no push or pull to the right, push or pull to the left? It's sign analysis really, again, on the second derivative of that position function, because that's what acceleration is. So, okay, let's start with the sign analysis process. You set the function, which is acceleration, equal to 0. And you solve for the time value. So this gives you 6t is 12, or t is what? Isn't that means 2 seconds? So 2 seconds, ladies and gentlemen. All right, what does sign analysis tell us again? Well, let's get out that real number line. This is sign analysis now on the second derivative, which is your acceleration. 2 seconds is over here. Remember, we have to throw out the negative t values because your time is always greater than or equal to 0. So this just becomes the sign analysis procedure from Algebra 2 or pre-calculus. All right, so hopefully that pre-calculus instructor did sign analysis, right? You could look back at my website. You guys know I did sign analysis for intermediate algebra, but it's called nonlinear inequalities. The process is sign analysis, but okay. Like before, I'm going to use a test point for region 1. What's available is a 1. And then maybe now I'll do a 3. It doesn't matter. So you say, what am I testing? I'm testing doing sign analysis on the acceleration. Okay. Plug in the test point of 1. You get 6 times 1 minus 12, which is 6 minus 12, and it's negative 6. So in region 1, the acceleration is negative. In region 1, you're being pulled to the left. Okay, now go to test region 2. 6 times 3 minus 12. It looks like that's 18 minus 12, which is 6. Region 2 is positive. All right. I have all the information I need. I just want to make sure. Left was orange. Region 1 is, this is to the left. Region 2 is to the right. Okay. So all I got to do now is look at my picture, and I can answer the question in terms of time, right? So the particle has no push or pull. When that acceleration is 0, and that happens when t equals 2 seconds. It's going to be pulled to the left when the acceleration is negative. So we got to look at this in terms of an interval, square bracket, parentheses. We don't include 2 because at 2, the acceleration is 0. It's not negative. 0 isn't negative. So that's, again, we write as 0 less than or equal to t, strictly less than 2. Look at that interval notation. That's when it's being pulled to the left. No push or pull happens when t is 2 seconds. Force is 0 at that point. Being pulled now to the right happens when your acceleration is positive, and that's positive in the green, which is really 2 to infinity. So 2 to infinity as interval notation, and that strictly means t has to be bigger than 2. So there's your conclusion, ladies and gentlemen, and the reason we care about what? Acceleration now. Okay, your first question. But these are like the questions from yesterday. I took the exact same functions. Okay, so what's the key again? That phrase is sign what? Sign analysis. All right, let's look at the next example. You guys, any questions on this sign analysis here? Nope. Do you guys remember how to do those sign analysis questions? So remember, the biggest obstacle for people isn't really the calculus, it's the algebra. Ooh, let's try this one. Let's try the acceleration function now. Remember, this is the one we started with today. This is the position function. And then notice we got the what? We got the velocity function here. Is that right? They want us to get the acceleration function and do sign analysis on that. So remember, you got this position function for t being greater or equal to 0. Okay. Acceleration. What's the definition of acceleration? Do you guys remember? It's the derivative of what? Velocity. This is also written as v prime of t. So I just want you guys to know that. Let's give you a little more notation. Now the velocity was 1 minus t squared over 1 plus t squared, I think. Isn't that the velocity function? Yeah. So, you know, we're going to have to use what here? Quotient rule. Did we study quotient rule by any chance? I think we did, didn't we? We did quotient rule. So let's get out quotient rule. Square, if you wanted to see every detail, we square this function, bring this function up, differentiate 1 minus t squared minus 1 minus t squared, differentiate. Let's get some room here. One plus t squared squared. All right. Okay. Minus 2t, and then this one here. What do you have to do to differentiate this function over here? Anybody remember? It's chain rule. It's power rule for chain rule. So you got to do that power rule for chain rule here. All right. Good. So this will be 2, 1 plus t squared to the first power times the chain, which is 2t. You now get 4t, 1 plus t squared. So, all right, we do have space. So, okay. We got 1 plus t squared to the fourth power, because that's 2 times 2. I'm going to put the negative 2 in front, plus t squared squared minus 1 minus t squared times 4t times 1 plus t squared here. Yeah. Looks pretty good. Okay. Now, I can actually do a few things here. I can use some. We're going to have to simplify. I can factor, which might help in the algebra. Factor out of 1 plus t squared, I get negative 2t times 1 plus t squared. Yeah. Minus a 4t times 1 minus t squared. I just factor out using algebra, and then this is 1 plus t squared to the 4th power here. I can even take out that negative from both terms. So it'll be out here. I can put the negative term out here. That makes both of these here now plus. So I even factored out a negative using algebra again. So, okay. That seemed to be pretty helpful for us. Here, we're going to have to distribute. Here we distribute. This is why I did what I did. But don't forget, there's a negative 1 plus t squared. Now, this will be 2t plus 2t cubed plus 4t minus, looks like it's 4t cubed. Double check. Okay. I can combine my like terms. And I'll get 6t now minus 2t cubed, it looks like, over 1 plus t squared to the 4th power. And then I want to kind of do something here for you guys. Get rid of that. That's now the 3rd power here. Minus 6t, I guess we can do it this way. 6t minus 2t cubed over 1 plus t squared cubed. I can factor out 3t. And I get 2 minus, looks like t squared, over 1 plus t squared cubed. And let me double check. No, I factor out a 2t. Okay. There we go. And this becomes, is that plus? No, it's still minus. Sorry, that's a minus sign here. Yeah, don't be careful here. This minus sign is already there at that level. This is a minus sign we factored out in the beginning here. So it looks like that's going to be good enough. All right, what is this? This is our acceleration. So as you guys can see, yes, there is algebra. That's what they want you to get. They want you to get the acceleration function. Okay. So we have to perform what on this function? The sign analysis on that function. You go, okay, what is sign analysis on that? Well, you got to find. So let me copy this because I don't want to. You got to find, again, we're going to need more space here. Where is the numerator 0? Where is the denominator 0? Two t minus 3t squared is 0, and the other section is 1 plus t squared cubed equals 0. So we're doing sign analysis. So just kind of take a look at that. Oops, I wanted to go only here for the numerator. Take a look at the denominator. And now here, that means 2t is 0. it means 3 minus t squared is 0. This means t is 0. Good. I like that. The second equation, this is by zero product rule using algebra to solve an equation. That's t squared is 3. Square root formula, t is plus or minus the square root of 3. That means t is positive square root of 3. And t is negative. However, you guys already know throughout the negative, because t is always greater than or equal to 0 for position functions. That's what this is. Here, when the base of the third power is 0, that means your base is 0, which means 1 plus t squared equals 0. And again, this never happens for a real number value. You can't have 1 plus t squared equal to 0. So you throw it out, is what I'm saying. So for sign analysis now, you're going to have 0 and the square root of 3. You got to use those two solutions. Okay, so this is sign analysis on the acceleration function. It is 0 and 0 here. So remember, you got to throw out what? The negative portion. T is greater than or equal to 0. You only have, well, you have 2 regions here, not 3 regions for sign analysis. So remember, the whole idea is to get the second derivative now, do your sign analysis. We need test points. So in region 1, the number 1's available. And region 2, the number 2 is available, because the square root of 3 is between 1 and 2. Is that right? I forget exactly what it is. So these are some really good test points to use, 1 and 2, on the acceleration function. But I got to go back and make sure I get the acceleration function right here. Okay? Because you're testing the sign on the acceleration function for these test points. You already know where acceleration is 0 here. When t is 0 and when t is the square root of 3. So that's when the particle is stopped. No, take it back. No, has no pull. No push or pull. It could still be, let me just say it that way. Now let's check this here. T is 1. You get negative 2 times 1. 3 minus 1 squared over 1 plus 1 squared cubed. I want to point out something to you guys. The denominator is positive. We don't even have to get the value. The numerator now, I'm going to put the sign in the numerator. It's really down here. But I'm going to put that I'm going to put it on the numerator because I can. You say, what do you mean? A negative fraction is negative a over negative b, or it is a over negative b. I used to teach this in pre-algebra to students. Students had to see that. They weren't quite sure where to put the negative. So we can say this is going to be negative 2 times 3 minus 1, positive 2. You got a negative over a positive. What does that give you? Region 1 is negative. Your particle is being pulled to the left. 2 now. Do the same for 2. So plug in 2. Here, here, here. We get negative 4. 3 minus 2 squared. Isn't that 4? 3 plus, let's see, 2 squared, that's 4. Again, my denominator is positive, But my numerator now, I can look at that as -4 times -1. Oh, that's also positive because I put that negative sign on top. Positive over a positive means region 2 is positive. So, ladies and gentlemen, yes, we have all that information here now. We're just doing sign analysis for a rational function. What colors did I use? Being pulled to the left was orange. Okay. Being pulled to the left, being pulled to the right. So everything you need to know, just look at this what? Just look at this picture now. So I could get rid of all the drama now. So I can get rid of all that, yeah. Even this. Let's look at the conclusion. This is acceleration. So there is no pull. When is there no pull? When acceleration is 0, and that happens at 2 locations. T is 0, and t is the square root of 3. Those are in seconds, by the way. Okay? There is no pull, no force at these time values. You're going to be pulled to the left, though. Let's call that a left pull. How's that? When acceleration is negative. And that's going to happen in this interval here. Now, notice, these are 2 open intervals. Why do they have to be open? Do you guys know why they have to be open? Because at 0 and the square root of 3, acceleration equals 0. We're looking for negative acceleration. 0 is not negative, so we don't include the 0 or the square root of 3. So this is what it looks like as an interval notation. That's now 0 strictly less than t, less than the square root of 3. That's when the particle has a left pull or being pulled to the left. You can see it in the sign analysis picture. This is why you do it. A picture's worth 1,000 words. Now you have a right pull, and you go, okay. What's a right pull? Well, when your acceleration is positive. When does that happen? Well, it happens not at the square root of 3. The square root of 3, it equals 0, but from the square root of 3 on forever. Interval notation. You write it as t being strictly greater than what? Square root of 3. And so, ladies and gentlemen, you know, this is how we do what? Work with sign analysis on the second derivative, and that represents acceleration for a position function. But now you're talking about how a particle is being pulled to the left, pulled to the right, or not pulled at all. And so this information is valuable because what's going to happen in our future, we'll answer questions like, for another example here, question number 3 on acceleration, to talk, it's kind of to warm up a bit. I am still going to get you some of those other solutions like I promised, but with the game on the way it is, it's made things a little difficult for me, but you know, I'll get that to you guys as soon as possible. But let me try to get this. Oh, whatever. Okay, but maybe before we start, let's get some administrative chores out of the way. Your test is on Monday, and what I added is a what? Study guide for you guys. Is that right? You guys notice that? It's an extra credit study guide. So you'll have that here for you guys. Your actual test is much shorter than this, by the way. But, this should serve as a pretty good study guide for you guys on things, I would say. And there's some things we do still have to discuss, and we will. But anyway, your test is actually shorter than this, much shorter. So you do have this as an option for extra credit, and you've asked for that. And it's designed to prepare you for your what? For your test. So it is an extra credit assignment there worth 10 points. And so we got that out of the way to let you guys know. But let's continue to see some of these kind of questions that you might see on your test. And here we go. Come on here. All right. Well, this is still going to be about acceleration. And that's an acceleration of a particle. Okay, given the position function s of t here. Here's our position function s of t. T is always greater than or equal to 0. But this is not the velocity worksheet. This is the acceleration worksheet. So you already got this velocity in the past. In other words, it's on the prior worksheet on velocity, really called motion. So now we need acceleration. And what did we learn yesterday? What is acceleration? Do you guys remember? Acceleration is the derivative of velocity. Okay? This is actually known as v prime of t as well. So in terms of our notation, so we're going to find the acceleration function, which means differentiate 3t squared, right, minus 12. So let's get our acceleration function. And you guys should know by now, after all that practice, that's just going to give you a nice what? 6t. And so I want you guys to also note that acceleration is also the second derivative of the position function. And to answer all those questions about, when the particle is being pulled, because remember now they're going to ask you about these direction of being, they're going to ask you about how this particle is being pulled. You go, what do you mean the particle is pulled? Well, F equals what? ma. And you'll find from your physics classes F of t is mass times the acceleration function. And that depends on the value of t now. So if you recall, a force is a push or a pull. Okay? And it's based on that acceleration function that we just found, because mass is like a constant, okay? It's a number. Doesn't vary with time. Acceleration does. So when you think of acceleration, it's really about this force equation. There's a pull or a push in a particular direction. Okay, so we want to investigate all those ideas. That's going to be related to things we talk about and also stuff that's on your test. But to make a long story short, this is really an exercise on sign analysis on your acceleration function. So this is also in and of itself a pretty big exercise for the course, because this isn't going to be the first and only time you do sign analysis on derivatives. You'll see in the future you'll be doing more of that. So it's a good investment to review sign analysis. Sign analysis is not going away. Okay, so let's kind of get to the sign analysis. And that's really what this is kind of about in my mind to some degree, sign analysis on derivatives, and then reading what you have. So you already do, you have 6t. where t is greater than or equal to 0 now. So to perform sign analysis on that, if you guys recall, this is a nice linear equation. It's not irrational. So that means you just set the function equal to 0, which means 6t is 0. Solving for t means t is 0. So that's kind of an interesting situation. So when we do sign analysis on the acceleration function, first of all, the acceleration function, which is 6t, is 0 when t is 0. So that separates the real number line into two regions. If we did sign analysis the way you would do it in either a pre-calculus course or intermediate algebra. I sent you guys the intermediate algebra ones, right? And then what you would theoretically do is find test points in each region. You guys remember what I'm saying? You need a test point in each region. But in the context of motion, where is it? What do we say about our t value? Yeah, it could never be negative. So you throw out region number 1. So this is a nice, easy peasy version. Okay, so let's find a test point in region 1, like, for example, the number 1. So what are we testing? We're testing the sign of the acceleration function. We got to know what that acceleration function again is. Your acceleration function was 6t. Is that right? Because you got it right here. All right, so this is kind of a pretty simple sign analysis question. Because all you got to do is plug in your test point. And that test point is going to be 6 times 1, which is 6. What do we know about acceleration? And I should say the sign of the acceleration function in region 2. That 6 is nice and what? It's nice and positive. Is that right? And that's all you care about. So here, a of 1 is positive. Okay, now, you're looking at all the information you need to answer 3 questions. All right? Let's think about yesterday. What is this really about? It's about that concept called push or pull, and that's what acceleration is. I mean, if you ever get in a car and you're driving and your car is accelerating, you should feel a push or a pull. Maybe you're being pushed into the seat. You guys see what I'm saying? That's related to F is MA, your acceleration. So let's talk about what this meant as your conclusion. I want you guys to remember. When do you have no push or pull? I'll just say push. You got no push when the acceleration is equal to 0. What does that even mean, acceleration being 0? Do you guys know what that means? At what time is acceleration 0? The acceleration is 0 when t is 0, right? Because these are all those t values. T is 0 there. Good. So I'll give you guys a little bit more here, but that's kind of what they want to know. When there is no push or pull, that happens when t is 0. I will also remark is an acceleration the derivative of velocity? It is. We gave you guys that yesterday. When is a derivative 0? You guys know when is it 0 here? Let me find out. Let me put this here. Derivative 0. I can't even figure out what color to use. Maybe purple. What's the derivative of a constant? 0. So when your velocity, ladies and gentlemen, is c for constant, you got no push or what? Pull. That's an important detail as well. Saying velocity is constant is the same as saying your acceleration is 0. Let's think about driving a car. You put your foot on the what? On the accelerator, sorry. And you feel your body being pushed into the seat, and you notice that speedometer needle's going, increasing. And then when does your body start to move forward again into a position where there's no push or pull? When your velocity is stuck at a constant speed. When you drive home tonight, think about this. You're looking at the mathematics behind it. So when that speedometer stops and velocity is constant, you stop feeling that push or pull. And that's what they're talking about. There's no push or pull. I just say push when velocity is constant or when acceleration is 0. And that happens when at time t is 0. That's what that means. Just to kind of let you guys know. Okay, now you want to know this question too. So question number 2. When is the particle being pulled to the right? And I don't remember yesterday, what color did we use? I guess green. I'm big in colors because I think that helps people see things. The only region we tested was region 2, and that's positive acceleration. So positive acceleration means, right, being pulled to the right. And that happens for what values? Well, t is greater than 0 here. So remember, at 0, it equals 0. 0 is not positive. So that means as an interval, because I put that yesterday as well, that's 0 to what? Infinity, which means your time value is strictly what? Positive there. T is greater than 0. And that's when you got the particle being pulled to the right. Okay? And that's what you're seeing. And if I ask you, what's this question? When is the particle being pulled to the left? Well, that happens when your acceleration is negative. Okay, when is that acceleration negative due to sign analysis? What would you guys say? It's never negative. It's never negative. So that never what happens? So it's never pulled to the what? To the left, only pulled to the right. So this is the kind of things they're going to want you guys to answer. When is there no push or pull? When is it pulled to the right? When is it pulled to the left? Has anybody looked over the AI section on the website for some of these by any chance? Did you guys ever take a look at that stuff? I spent like all that time putting up for you guys as well. I put up the stuff. Yes.
When I tried using the math GPT, it has it like it gives a solution different than what, like, you know how for derivatives you have to do the definition formula?
Yeah.
It like gives
Well, that one was, yeah, you're right about that. What I've discovered, and one of the reasons why I agreed to do some of this stuff is this. I want to know about it, number one, and I know what it can do, what it can't do. And what I noticed when I put all my worksheets doing that work, and I watch what it does, and then they create the video, I'm like, that's really not what I want people to do. So in some cases, that stuff is a little odd. It doesn't work well. Some cases it does work well. It's a little weird to me, some of it, because it's like, is that the best you could do, ChatGPT? I thought you're going to take over the world. I don't see it taking over the world. But you're right. In some cases, like the notation is off. I think you have to do this. It gives you a prompt where you can enter things. You might be able to just be more descriptive with what you're asking. Like you might say, use the definition of a derivative to differentiate this function, and then see what it gives you. You can take a picture of the function and put it in there. So it's done in a way that allows you to interact with it. So that's why they call that the public chat. So that's, like I said, at this point, I'm not doing a deep dive. I suspect that may help, but it also may not. This is why I'm going to keep my videos there. I'm not going to delete any of my videos because ChatGTP is not, I should say, perfect at all. AI is not perfect, but it's a good start. And so some things work out well, some things not so well. So I get it. I understand. That's why I'm putting up my videos, and I'm not just saying, hey, I don't have to do videos anymore. No, I still do. So I will get to some of that. But speaking of ChatGTP, what is it called being pulled to the right? They said you are moving here forward. The particle says move forward, that's to the right. Move backwards. So the language of Math GTP, going to the right, they call moving forward. Going to the left, they call moving backwards. It's also known as going up or going down. And we'll kind of start to get a sense about why that's important for us to know. All right, so even some of the language they use is very specific. Moving forward, Mr. Judge never said what moving forward is. It's moving to the right or moving up. What is about moving backwards? Moving to the left or moving to the right. But this is being pulled forward now. You're being pulled forward, and you'll see the relationship, and pulled backwards. That's the language of it. But I wanted to warm up today by giving you guys another example, and I will send you more of the acceleration and sign analysis. Like I said, I'll send you more velocity and acceleration. I got to do the last two for each. Okay. We're going to work on the second derivative of the position function, right, which is called acceleration. So when we differentiate velocity, which is the derivative of s prime t, we now get, notation-wise, what we call the second derivative. So let's double check here. This is called higher order derivatives. All right. So notice this. We do have, again, the position function. And based on a past worksheet, yes, time is greater than or equal to 0. We computed the velocity function now. So let's get the acceleration here. So your acceleration is derivative of that velocity function, which will be d dt. Velocity is 3t squared minus 8t. So, all right. That derivative will be simply 6t minus 8. So the acceleration function here is 6t minus 8. Now remember, we're going to try to find where we have the push to the left, pull to the right, or push, pull, whatever you want to call it. Push to the left, push to the right, pull to the left, pull to the right. And when there's no push or pull, what they mean by that is simply perform sign analysis. On your acceleration function. So we start by letting that acceleration be 0. This is also, by the way, when you have velocity being a constant. But okay. Constant velocity gives acceleration is 0. So we can solve this for t now. That's what we want to do. Solve for t. If If I add 8 to both sides, we get 6t is 8. Divide both sides now by 6. T is 8/6, but what that really means is t is going to be 4/3 of your seconds. 4/3. All right. So by sign analysis again, on the acceleration function, 0's in the middle here. 4/3 is to the right. Now this is sign analysis on the acceleration function. So really we have two regions to consider, because remember your time again is greater than or equal to 0, which means we throw out, this portion of sign analysis. We didn't even consider it, but that's what we're going to do with this. Acceleration, we already know if we copy that, this is the acceleration function over here. All right, we need some time values. 4/3 is bigger than 1. So 1's available, and 4/3 is smaller than 2. So we're going to use those two test point values. Okay. We're going to test the region, test the signs. So when t is 1 now, you get 6 times 1 minus 8, which is 6 minus 8. That is -2. So in region 1 there, acceleration is actually negative. So the particle is being pulled to the left for those values there between 0 and 4/3. Okay, let's test the value of 2 in sign analysis. So here again, here's where 2 is. 2, you get what? 6 times 2 minus 8, which is 12 minus 8. The answer is 4 now. So, ladies and gentlemen, that's a positive 4. So, let's keep with our convention. I think going to the right was green, and going to the left was orange. But this is not velocity sign analysis, it's acceleration. We're talking push or pull now. So the first thing we want to know is where there's no pull, no push or pull. That happens when your acceleration is 0. That's also when you have, by the way, constant velocity. You'll have no push or pull, because that means acceleration will be 0. That happens when t here is 4/3 seconds. Because we already found where acceleration, this is acceleration function, is 0 at 4/3 seconds. Now, you're going to have, we'll call this we'll say pull to the right, okay, where your acceleration is strictly positive. That means it's for values of t on our sign analysis that are bigger than 4/3. So t has to be greater than 4/3 here. Greater than 4/3 seconds. As interval notation, that's 4/3 up to infinity. Okay. Pulled to the left now, negative acceleration. Now, we include 0 here. Okay, and that's open parentheses because at 4/3, acceleration equals 0. It's not negative. 0 is not negative. It's not positive. 0 is neutral. So we'll say now here for the pull to the left now, our left pull, your acceleration has to be negative. And then that happens again for t being between 0 and 4/3, but we include the 0. This is a square bracket here. And you say, why? Well, you don't have a 0 above 0. It's only above 4/3, so that means it's negative. Okay. In terms of interval notation, you have a closed bracket around 0 and an open bracket around 4/3. And, let's just color coordinate everything. There's no pull for this time. You got a right pull for this time. And then you got a left pull for this time. So, ladies and gentlemen, there you guys go. This is how this works here. It's your sign analysis. All right, let's try this out again for question number 5. Question 5, we had the position function for time values being greater than or equal to 0. Then we computed the velocity function. This is about acceleration now. So acceleration is the derivative of velocity. Give you every detail. Velocity is 15t squared minus 8t. When I differentiate, we get 30t minus 8. Here's our acceleration function. This is what we have to form sign analysis on. So you got sign analysis on the acceleration function. All right, start by setting the acceleration function equal to 0 and solve for t, because this is the process of sign analysis. Solve for t now. So 30t is 8. Divide both sides by 30. T is going to be 8 over 30. That reduces to 4 over 15, and this is seconds. Okay, this is how we go about this again. So we only have one value. I'll label 0. 4 over 15, this is the acceleration function. This is where acceleration is 0. It's not 0, ladies and gentlemen, when t is 0. And just remember, we have to throw out the time values that are negative because we're dealing strictly with t being greater than or equal to 0. So that portion is gone. We have region 1, region 2, if you want to call it that. Let's look at it this way, maybe. Right? Don't forget to bring down your acceleration function, and I might just keep it blue. That looks a little better. Let's copy that. All right. We need test points now. So let's be careful. In region 1, we got 4/15. I'm going to use like 1/15. Then we use the number 1. These are going to be my 2 test points. I'm picking a number in region 1 I could test the sign with. So 1/15, we get 30 times 1/15 minus 8. That'll be 2 minus 8, which is -6. So double check. I know that 15 is doing something weird. 30 times 1/15 is 2. So region number 1 is negative. The particle is being pulled to the left in region 1. Okay. We're going to do the test point now of 1 and see the sign of region 2. So this gives me 30 times 1 minus 8. And again, I don't like that. I don't know why it does that. 30 times 1 minus 8 gives you 30 minus 8. And that's going to be a positive 22. Region 2 is positive for acceleration. So we're being pulled to the right in region 2, and we're being pulled to the left in region 1. There is no pull when t is 4/15. So, ladies and gentlemen, we're ready to formally answer our push and pull, really acceleration questions. All right, let's see what that means here. So your particle is really no push or pull. You have we'll say no pull when acceleration is 0, and then that happens when t is 4/15 seconds. We already answered that. That's what they're talking about right here. Particle will be pulled to the right when your acceleration is strictly positive. Well, the acceleration again is strictly positive over in region number 2. So we're going to use that open parentheses. What that's a picture of is saying all the time values are bigger than 4/15 of a second. That's when you're going to have what we call a right pull. You want a left pull. I guess, I don't know, how are we saying that? Left pull, pull to the right. Which one? Pull to the left. Okay. Guess we want the word pull first, but it doesn't matter. Particles being pulled to the left when your acceleration is negative. Acceleration is negative, ladies and gentlemen, right in this interval here between 0 and 4/15. That's because of our sign analysis. So what does that mean? And let me be careful again, because at 0, we don't have a 0 up above it. So at 0, it's a square bracket. We include 0. 0 to 4/15. So we're going to say 0 less than or equal to t less than the 4/15 of a second here. And then that's where you have the left pull. So there's your information on acceleration. No pull, pull to the right, pull to the left. Sign analysis on the second derivative of the position function, which means it's acceleration. And then that's question 5, and that means we're done. So I'll send this to you guys as well, and I hope you enjoyed the demonstration.